let's have a look at question 6. Now we've got the line y equals x take 2, which is just a straight line, positive gradient, y intersect at -2. We've got the cubic, y equals x cubed take 5x squared take 6 plus 6x, which we discovered in question 4. It factors down to x take 2, x take 3. Yep. And we're sketching where these two lines meet. We're obviously not doing a good job of it. I say that every time, like you just have to do a really vague sketch of a cubic and stuff. Okay, so let's get that straight line positive going through the line, the point x equals -2. It's going to keep going up like that. So that's y equals x take 2. Now let's put in our cubic. It has intercepts there, there, and there. So assuming there, there, and there. Okay, so this one is alpha. This one, well, they've cheated. They've already told us this one to 0, and they'd like us to call this third one beta. Normally I would have called it at delta, but whatever. Okay, usual first step. X take 2 equals x squared, cubed take 5x squared plus 6x. Take it all over to one side. I get x cubed take 6x squared. Take 5x squared. Plus, because I'm subtracting that x, 5x plus 2. Done. Okay, so that was A. For B, we want to find alpha plus beta. We know that the roots of a cubic, alpha plus beta plus gamma, equals minus b on A. So alpha plus beta plus our third root, which was 2, they've told us, equals minus b on A, which is minus -5 on 1, so it equals 5. So alpha plus beta plus 2 equals 5, so alpha plus beta equals 3. So the coordinates of the midpoint, well, it's x1 plus x2 over 2, like you add them together and halve it, so this time it's alpha plus beta over 2, so this is the x coordinate. So x equals 3 over 2. Y, we sub this in. So I've got 3 over 2 take 2. So y equals -1/2. So the midpoint is at 3 over 2 -1/2. Okay, for C, show that this thing, them times together equals -1, and then use that identity. I'm going to copy this question. Now, when we have roots, we know for a cubic, alpha times beta times gamma equals C on A, yeah? So here, alpha times beta times, well, we know gamma, it's 2, equals C. C was +5 on 1. That's not going to get me that equals -1. Oh, no, this one, it's not C on A, it's -D on A. I need to get my list of rules out again from exercise 10F. -D on A, so this time we've got minus, what was D for this one? 2. Yep. So we've got alpha times beta times 2 equals -2. So alpha times beta is -1. Okay, we've done the first part of it. Now, alpha take beta squared equals alpha plus beta squared take 4 alpha beta. We know alpha plus beta, what did it come out as? 3. Take 4 times, and this came out as -1. So we've got 9 plus 4 equals 13. So we know alpha take beta squared equals 13, which means the absolute value, so the positive alpha take beta, is the positive square root of 13. Ah, done. Finally, question D, hence use Pythagoras' theorem to find the length AB. Now, I'm going to copy and paste this. You don't need to have this. Now, what we've found is we've found this length between these 2 points. We found that that's root 13. We don't know this length between the 2 points, and that's the run between them, by the way. And this will be the rise. And then this length is what we're actually trying to find. So, and we know the gradient of this line, because that's y equals x take 2. The gradient is 1. So we've got a few things first to find out. So firstly, we need to find out the rise. So, if the change in x was, so x went along by root 13, then the rise equals root 13 times 1, because the gradient was 1. Yeah? Because the gradient is rise over run. So 1 equals the rise over root 13. So rise equals root 13. I'm just going to get rid of this. Then using Pythagoras, the hypotenuse, which is the distance between point A, and point B, so it's the distance along this line. Well, that squared equals root 13 squared plus root 13 squared. So the distance AB equals the square root of this answer, which is the square root of 26. That's question 6 for us.